Imagine compressing Earth down to the size of a peanut. That's the level of compression needed to turn our planet into a black hole. Now take it even further, compress the entire observable universe, including trillions of galaxies, stars, planets, and even you, into something smaller than a proton. That would form a singularity, an incredibly dense point that marks the beginning of our universe. This is where the Big Bang begins, or at least, what we call the beginning. But what if it wasn't truly the beginning of everything? Contrary to what you might expect, the Big Bang didn't happen at a single point in space. It happened everywhere at once. In fact, it wasn't an explosion in space, it was an expansion of space itself. Before this event, there was no space and no time. Everything existed within that tiny singularity. Because of this, the universe doesn't have a center. Every point in space is moving away from every other point, meaning every location can be considered the center, and yet none truly is. To witness the Big Bang, you wouldn't travel to a place, you'd travel back in time, about 13.8 billion years. As you move backward, the universe would shrink. Galaxies would move closer together, stars would reverse their life cycles, and supernova explosions would pull themselves back into massive stars. Eventually, matter itself would break down. Atoms couldn't hold together under the extreme heat and pressure, turning everything into a dense, hot plasma. As you approach the very beginning, conditions become almost unimaginable. Temperatures would soar to around 10 superscript 3 superscript 2 Kelvin, far hotter than anything we can comprehend. At this point, even fundamental particles couldn't exist in stable forms. Space and time themselves begin to lose meaning. Technically, there would be no before the Big Bang, because time as we know it wouldn't exist yet. Then comes the moment of inflation. In a fraction of a second, far shorter than a blink of an eye, the universe expanded incredibly fast. This rapid expansion set the stage for everything that followed. Shortly after, the universe was filled with a hot, dense plasma. Interestingly, it wasn't empty space yet, so sound waves could actually travel through it. These early vibrations, known as baryon acoustic oscillations, rippled through the universe like deep, cosmic echoes. At first, the universe was opaque, like a thick fog. Light couldn't travel freely because it constantly scattered off particles. It took about 380,000 years for the universe to cool enough for light to move in straight lines. This moment left behind a faint glow we can still detect today, the cosmic microwave background, a kind of afterimage of the early universe. As time went on, gravity pulled matter together, forming the first stars around 200 million years later. These stars were massive and short-lived, eventually exploding and creating heavier elements like carbon, oxygen, and iron, the building blocks of life. Over hundreds of millions of years, galaxies began to form. Billions of years later, our sun and solar system emerged. Today, the universe is still expanding, and not just expanding, but accelerating. Scientists observe this through redshift, where light from distant galaxies stretches as they move away from us. However, what's driving this accelerated expansion remains a mystery. While the Big Bang explains how the universe evolved from a hot, dense state, it doesn't fully answer what came before. Some theories suggest a big bounce, where the universe expands and collapses in cycles. Others propose cosmic inflation or even the existence of multiple universes in a vast multiverse. In the end, the Big Bang may not be the absolute beginning, but rather one chapter in a much larger cosmic story, one we are only just beginning to understand.